This video will cover beginner questions regarding the topic of integration inverse trigonometric functions. We already know the formulas for differentiating inverse functions, so we know these basic integral formulas. But rather than these basic formulas above, you can find integrals much faster if you remember the formulas below. Let's prove the first of the three formulas below. The method of proof using substitution is the same for the other two formulas. The integral of dx over square root of a squared minus x squared equals the integral of dx over square root of, take out a squared, open the bracket, 1 minus x squared over a squared equals the integral of dx over a squared is outside of the square root, then we get a, then square root of 1 minus x squared over a squared equals integral of dx over a square root of 1 minus, we can rewrite as x over a then squared. Use U substitution. U is x over a, derive on each side, du equals 1 over a dx equals the integral of 1 over a dx is du over square root of 1 minus x over a is u squared equals, we already know the integral of 1 over square root of 1 minus x squared dx equals arcsine of x plus c. So this one is arcsine of u plus c equals arcsine of u was x over a plus c. So we get the formula. When proving, the variable is written as x, and when writing the formula, the variable is written as u. The reason is that we will use u substitution for the part written as u. If you forgot the integral formula, this is how you should start. We have to use this basic formula. Integral of 1 over square root of 1 minus x squared dx equals arcsine of x plus c. The integral of 1 over square root of, take out 4, open the bracket, inside of the bracket is 1 minus x squared over 4 dx equals the integral of 1 over square root of 4 is 2, then square root of 1 minus x over 2 squared dx. Now use u substitution. Let u equal x over 2, then derive on each side, du equals 1 over 2 dx. Change all x into u. The integral of 1 over 2 dx equals du square root of 1 minus x over 2 is u squared equals, from here, arcsine of u plus c equals arcsine of u was x over 2 plus c. But if you remember the formula, let's see how fast we can find the integral. Comparing with the formula, a squared is 4. That means a equals 2. U squared is x squared. That means u equals x. The answer is arcsine u over a, u is x, over a is 2, plus c. We have the same answer. How is it? Not all integrals are this fast using the formula, but they are much faster than using only the basic formula. Number 2, remember the formula. The integral of 1 over square root of a squared minus u squared du equals a cosine of u over a plus c. Now let's look at the formula and change the shape. Inside of the square root, there is a difference between two squares. So the integral of dx over square root of 1 squared minus, we can rewrite as 3x squared. Use u substitution. Let u equal 3x. Derive on each side. Du equals 3 dx. There is only dx. Then divide by 3 on each side. Du over 3 equals cancelled dx. Now change all x into u. The integral of dx equals du over 3. Then 1 over square root of 1 squared minus 3x squared is u squared. Then we can rewrite as 1 over 3, the integral of 1 over square root of 1 squared minus u squared du equals 1 over 3 times a squared is 1 squared. That means a equals 1. Then u squared is u squared, the same thing. The answer is a cosine of u over a. Then u over a is 1 plus c. So 1 over 3, a cosine of u was 3x plus c. Number 3, we can rewrite as the integral of 3x over square root of 1 minus x squared, then squared dx. Use u substitution. Let u equal x squared, then derive on each side. Du equals 2x dx. Then divide by 2 on each side. Du over 2 equals 2 is cancelled, x dx. Change all x with u. Integral of 3 x dx is du over 2 square root of 1 minus x squared is u, then squared, equals, we can rewrite as 3 over 2, the integral of 1 over square root of 1 minus u squared du. And then please remember the formula. The integral of 1 over square root of a squared minus u squared du equals a cosine u over a plus c. Then use this. The answer is 3 over 2. A squared is 1. That means a equals 1. U squared is a u squared. So a cosine of u over a is 1 plus c equals 3 over 2. A cosine of u was x squared plus c. Number 4. Usually, when students look at this question, they think it is a cosecant because there is an x before the square root. But let's compare the two formulas here. The integral of 1 over square root of a squared minus u squared du equals arcsine u over a plus c, the integral of 1 over u square root of u squared minus a squared du equals 1 over a arcsecant of u over a plus c. The important thing here is the order of square numbers in the square root. For the integral to be arcsine, it is the square of the number minus the square of the variable. And for the integral to be arcsecant, it is the square root of the variable minus the square of the number. This integral becomes arcsine because the variable comes later. Now use u-substitution. Let u equal ln x, derive on each side, du equals 1 over x dx. The integral of 1 over x dx equals du, then 1 over square root of 4 minus ln x squared is u squared. Use this. A squared equals 4. That means a equals 2. U squared is u squared. The answer is arcsine of u over a, which is 2, plus c equals, the final answer is arcsine of u equals ln x over 2 plus c. Number 5, use the formula. The integral of 1 over a squared plus u squared du equals 1 over a arctangent u over a plus c. We can rewrite as 3 is here, the integral of 1 over 4 squared plus x squared dx. In here, a squared is 4 squared. That means a equals 4. U squared is x squared. That means u equals x. So 3 times 1 over a, 1 over a is 4, arctangent u over a, u is x, over a is 4, plus c. The final answer is 3 over 4, arctangent x over 4, plus c. Number 6, use the formula. The integral of 1 over a squared plus u squared du equals 1 over a arctangent u over a plus c. So we can rewrite as the integral of dx over 3 plus 2x squared. Then let u equal 2x. Derive on each side. Du equals 2 times dx. There is only dx, so divide by 2 on each side. Du over 2 equals 2 is cancelled, dx. Then change all x into u. The integral of dx is du over 2, then 1 over 3 plus 2x squared is u squared. Then we can rewrite as 1 over 2, the integral of 1 over 3 plus u squared du. In here, a squared is 3, That means a equals the square root of 3. So 1 over 2 times 1 over a is 1 over a is the square root of 3. Arctangent of u over a, u is 2x over a is the square root of 3 plus c. The final answer is 1 over 2 square root of 3 arctangent of 2x over square root of 3 plus c. Number 7, we can rewrite as the integral of x over x squared then squared plus 9 dx. Now use u substitution. Let u equal x squared, then derive on each side du equals 2x dx. There is only x dx, then divide by 2 on each side. Du over 2 equals 2 is cancelled, x dx. Now all x into u, the integral of x dx is du over 2, and 1 over x squared is u, then u squared plus 9. We can rewrite as 1 over 2, the integral of 1 over 9 plus u squared du. Then use the integral of 1 over a squared plus u squared du equals 1 over a arctangent u over a plus c. 1 over 2 times, in here a squared equals 9. That means a is 3. So 1 over a means 1 over 3 arctangent u over a, then u is x squared over a is 3 plus c. The final answer is 1 over 6 arctangent x squared over 3 plus c. Number 8. Perhaps the most difficult integral among the questions in beginners is this integral involving arcsecant. Use this, the integral of 1 over u times square root of u squared minus a squared du equals 1 over a arcsecant u over a plus c. We can rewrite as the integral of 1 over x times the square root of 3x squared minus 4 dx. There are u and u squared, but here is x and 3x squared. Don't worry about it. It is always important to organize the variables within the square root. Substituting variables outside of the square root is sufficient after that. So, shall we replace it now? Use u substitution. U equals 3x. Derive on each side. Du equals 3 dx. There is only dx. Then divide by 3 on each side. Du over 3 equals cancelled dx. From here, divide by 3 on each side. Then u over 3 equals x. Now change all x into u. The integral of 1 over x is u over 3. The square root of 3x squared. 3x is u squared minus 4. Then dx equals du over 3. Now 3 is cancelled. Then we can rewrite as the integral of 1 over u square root of u squared minus 4 du. Now use this a squared equals 4. That means a equals 2. The answer is 1 over a, 1 over 2, cosecant u over a, so u over a is 2, plus c. The final answer is 1 over 2, cosecant u was 3x over 2 plus c. Usually, when students look at this question, they think it is arcsine because there is no variable outside of the square root, as we have already said when explaining question 4. Let's compare the two formulas once again. The integral of 1 over square root of a squared minus u squared du equals arcsine of u over a plus c. A squared minus u squared means the number squared minus the variable squared. And integral of 1 over u square root of u squared minus a squared du equals 1 over a cosecant u over a plus c. U is outside of the square root, and inside of the square root there is u squared minus a squared. That means the variable squared minus the number squared. Look at the integral. We can rewrite as the integral of 1 over square root of e to the power of x squared minus 1 dx. So now let's see how to become cosecant. Use U-substitution. Let u equal e to the power of x. Then du equals e to the power of x dx. There is only dx. Then divide by e to the power of x on each side. Du over e to the power of x equals cancelled, then dx. And e to the power of x is u, then we can rewrite as du over u equals dx. Now change all x into u. The integral of 1 over square root of e to the power of x squared. That means u squared minus 1 dx equals du over u. Then we can rewrite as the integral of 1 over u, then square root of u squared minus 1 du. Now use this formula. A squared equals 1. That means a equals 1. The answer is 1 over a. The 1 over a is 1. Cosecant u over a, u is e to the power of x, over a is 1, plus c. The final answer is cosecant e to the power of x plus c. Question 10. We can rewrite as 4 over x times square root of x squared, then squared minus 9 dx. Let u equal x squared, then derive on each side. Du equals 2x dx. Then divide by x on each side. Du over x equals 2 dx. There is 4 dx, then times 2 on each side. 2 du over x equals 4 dx. Integral of 1 over x square root of x squared is u, u squared minus 9 times 4 dx is 2 du over x equals to the integral of x times x is x squared, which is u, then square root of u squared minus 9 du. Now use the integral of 1 over u times the square root of u squared minus a squared du equals 1 over a cosecant u over a plus c. In here, a squared is 9. That means a equals 3. The answer is 2 times 1 over a, 1 over 3, cosecant u over a is 3 plus c. Then final answer is 2 over 3 cosecant of u is x squared over 3 plus c. A point to note when evaluating the definite integral using substitution is that when a variable changes, the limit of integration for x is also changed to the integration limit for u. Let's check. Use the formula. The integral of 1 over square root of a squared minus u squared du equals cosine of u over a plus c. We can rewrite as the integral of 0 to 3 over 4 dx over square root of 9 minus 2x squared. Use u substitution. Let u is 2x. Derive on each side. Du equals 2 dx. There is only dx. Then divide by 2 on each side. Du over 2 equals 2 is cancelled dx. Let's change the upper limit. When x equals 3 over 4, then u of 3 over 4 equals 2 times 3 over 4, then 2 times 1, 2 times 2, which is 3 over 2. So the new upper limit is 3 over 2. When x equals 0, u of 0 equals 2 times 0 equals 0. Now change all x into u. The integral of 3 over 4 is now 3 over 2. 0 is 0. Then dx is du over 2. Then 1 over square root of 9 minus 2x is u squared. So we can rewrite as 1 over 2, the integral of 0 to 3 over 2, 1 over square root of 3 squared minus u squared du. From here, a squared is 3 squared. That means a equals 3. So 1 over 2 cosine of u over a, then u over 3, 0 to 3 over 2. We do not return to the variable x after integrating. We just evaluate the expression in u using the changed limit of integration. Equals 1 over 2 cosine of the first one 3 over 2 over 3 minus cosine of 0 over 3 equals 1 over 2 cosine of 3 over 2 over 3 equals 3 over 2 divided by 3 That means 3 over 2 times 1 over 3 cancelled. Answer is 1 over 2. Or 3 over 2 over 3 is actually 3 over 1. Then outside over inside is 1 over 2. Then back to the original, minus arc sine of 0 over 3 is 0. Equals 1 over 2 times, when theta is pi over 6, the ratio is 2, 1 square root of 3. Then sine pi over 6 is 1 over 2. That means arcsine of 1 over 2 is pi over 6 minus 0. Then final answer is pi over 12. This is the last one. We can rewrite as 6 times square root of 3 to 3, 1 over 3 squared plus x squared dx. Use this, the integral of 1 over a squared plus u squared du equals 1 over a arctangent u over a plus c. From here, a squared is 3 squared. That means a equals 3. Then 6 times 1 over a is 1 over 3 arctangent u over a. U is x, then x over a is 3. Upper limit is 3, lower limit is square root of 3. We can rewrite as 2 times arctangent of x over 3 square root of 3 to 3. Now evaluate the expression. 2 times arctangent, upper limit is 3, minus arctangent, lower limit is square root of 3. Then we can rewrite as 2 times arctangent of 1 minus arctangent of 1 over square root of 3. When theta equals pi over 4, the ratio of the triangle is 1, 1, and square root of 2. Then tangent pi over 4 equals 1. That means arctangent of 1 equals pi over 4. When theta equals pi over 6, the ratio of the triangle is 2, 1, and square root of 3. Then tangent pi over 6 equals 1 over square root of 3. That means arctangent of 1 over square root of 3 equals pi over 6. Then back to the original. 2 times this one is pi over 4 minus this one is pi over 6 equals 2 times, make the same denominator, times 3 on each side, which is 3 pi minus 2 pi. Answer is 2 times pi over 12. The final answer is pi over 6. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.